problem. Alright, so looking at this problem, we have found before, so you'll notice I've gone back to a limit question because all of our derivatives are really limits. We've just found shortcuts that work for them. The actual definition of derivative went back to limits. And a trick that we've known is the limit as x approaches 0 of sine x over x equals what? 1. This is going to be true for some different manipulations of this. It would be true anytime the angle and the denominator are the same and approaching 0. So for instance, the limit as x approaches 0 of sine 2x over 2x is also going to equal 1. If those match and they're going to 0, then it would work. It's not going to work for sine of x plus 2 over x plus 2 because that's approaching 2, not 0. Does that make sense? So it only works if
Like the denominator equals 0, right? Is that what you mean?
if these things match, and with whatever you're approaching, it goes to 0. So if I change this to be the limit as x approaches -2, then that would actually turn into a 1. If I gave you this problem, my angle is a 7x. So we could go back to all of our fancy trig functions and do sum and difference formulas and double angle formulas and use all those identities to try to split this up. Or we could realize as x approaches 0, 7x is turning into 0, right? So if I could get this to be sine of 7x over 7x, then I could evaluate that. Would you guys agree? So I need to get a 7 on the denominator. But I can't change my problem, so if I'm going to multiply the bottom by 7, I'm going to take the top times 7. Now, what I have right now, I'm going to write it like this. That 7 would go out in front on top. On the bottom I have 4 times the next times the 7, so I'm going to rewrite it like this. I'm going to separate out this stuff I don't want, the 7/4. Then that would leave me with sine of 7x over 7x. You guys see how I manipulated that? So now, as x goes to 0, 7/4 is just going to go to 7/4, it doesn't have an x in it. Sine 7x over 7x is going to go to 1. And I get 7/4 for my final answer.
So that doesn't, we don't do the derivative in that one?
This one did not ask for the derivative, it just wanted the limit.
What's the limit is the derivative?
The limit as x approaches h of, that whole thing is the derivative. So a limit is the derivative is the limit. We had a couple different definitions, like we had the x approaches h of f of x plus h minus f of x all over h. That limit there was the derivative. So a derivative is one specific case of a limit, if that makes sense. Other questions? Look at this one. look at this, can you just plug in 0 from the beginning? No, tangent of 0 is 0, divided by 0, I can't do that. What could I do?
That's only 3.
Okay. Yes, but hold on a second. We have to get it to be sine x over x. So how could I change my tangent?
Break into sine, cosine.
Let's do that first. Okay. We don't like fractions and fractions, so that's like an x over 1. We could flip and multiply. So that'll turn it into sine 3x over x cosine 3x. So everybody see how we've manipulated it? You can see you've not quit frowning since I started.
Why do you put the 3 on top of it?
That's the angle. So since it's the angle on tangent, it has to go with both of them.
How do you get the x off the bottom again?
I said, well, dividing by fractions is the same as multiplying over by the reciprocal. Other questions? Okay. So it's still 0 over 0 if I were just to plug in. But let's kind of rewrite some of this. We want to get sine 3x over 3x. So I'm just going to pull this cosine apart. Okay, would you guys agree if I went ahead and multiplied these two fractions, I get back to what I was starting with? To be able to evaluate this one, I need it to be sine 3x over 3x. If I am going to add a 3 on the bottom, you also need to add a 3 on the top. You could put it in either fraction. Since I don't really want it here, can I just put it over there?
Yeah.
Does that confuse you guys?
You can put it in a fraction.
Yeah, because you're multiplying them. Okay. So now, as x approaches 0, sine 3x over 3x will go to 1 times, this is 3 over, what is the cosine of 0? So you get 1 times 3, which is 3.
How'd you get that to be 0?
When you plug in a 0 for your x.
I always want to be able to create things like the sum of force and the
Those will give you a good indicator. It's not guaranteed, but very likely. And she was just saying these, like, this problem, if you had a 7 here and a 4 here, and we got 7/4. This angle is a 3x, and we got 3. That's partly pattern and partly coincidence. So, okay, try another one. Take a second, see if you can figure out what you can do here. Added a square root in this, which is really tempting, but remember you can't change your problem. So you can only add a square root if you had an equation, and you could do it on both sides of the equation. But what you could do, sine squared means you have 2 sines. Theta squared means you have 2 thetas. Sine theta over theta turns into 1 times 1, and you get 1. So you start out by making this sine 2z over z, 1 over cosine 3z. We need this to be sine 2z over 2z. So if I add a 2 on the bottom, you have to do it on top as well. So then this turns into 1 times 2 over cosine 3 times 0 is 0. So you get 2. Let's take a blue. Alright. Thoughts? Divide it up. So sine 3 theta squared I have a theta squared, so I'm going to put a theta under each of them. I have this cosine on the bottom, so I'm just going to leave that as 1 over cosine theta. Alright, you know what I've done there? So next step. This needs to be sine 3 theta over 3 theta. So if you put a 3 on the bottom, you've got to put a 3 on top. This one also needs to be 3 theta. So I have to put another 3 on top. So sine 3 theta over 3 theta would go to 1 times 1 times 9 over cosine of 0 is 1. We get 9. Alright, so here's an easy one for you.
Thank you.
You're welcome. What do you do?
Add 2 on top of 1.
So then what do you get?
2.
2. Just that turns into a 1 times 2 instead of 2. Okay. Now we've got our confidence up. Let's look at this one.
Killing me.
Any ideas?
Well, the only thing I can think of is going to
Art formulas?
Yeah.
Doing a double angle or something?
But there's probably an easier way to do it.
Yeah, we might be able to get through that way, but it's going to be a long battle. So let's see if we have any other options. If I just plug in 0 right now, we just have 0 over 0, right? But you don't have an equation to do both sides. So whatever we do has to be legal. You could take them apart as writing it sine 2x, let's say over 1, and 1 over sine 5x. That's legal.
What would you do with 1 over sine 4x?
That's a good question. This property that we've been using, I've been telling you that turns into 1. So the question is, what if it was reversed?
It equals negative 1.
Would you guys agree? Okay, this is kind of a leap, but I think you'll be able to follow me. that is the same as 1 over sine theta over theta.
I would agree.
Okay. If I gave you this, you would flip and multiply, right? So it'd be 1 times theta over sine theta, which is this. Okay? If we did that, we'd have 1 over, what's the limit of the bottom?
One. But it's still like one.
So if it's flipped, it's still 1. So that's good to know.
They're on both, stopping at the bottom.
So what am I missing in this to be able to do it?
And just the plain x by itself.
Could you multiply it by x? If you put it on the bottom, you have to put it on the top. So that would be legal. Okay, what do I need this one to be? Mm-hmm. So right now I've gotten sine 2x over x and x over sine 5x. So this one needs a 2 on the bottom. Do I need a 2 on top anywhere? So I'm just going to throw it out to the side here. This one needs what? A 5 on top, so to cancel it you need 5 on the bottom. So now sine 2x over 2x goes to 1. 5x over sine 5x goes to 1 times 2/5. We get 2/5. Kind of fun, isn't it? I like it.
Okay, so it won't always equal the coefficients of the angles.
No, not always. If you look at like this one, even if I had put a different number down here, even like a 4, you would have gotten the same thing. So it has to do with which functions you have, if it matters now. Alright, you guys try the last one. So what we have is x cosine x over sine x. So I would separate that. Do x over sine x. Then I just have my cosine x by itself. X over sine x goes to 1. Cosine of 0 is 1. And we get 1. So that's really the end of this piece. So we are done with section. Tomorrow I'll probably we'll grade all this homework, probably do some review problems, and then I've got a review handout for you, which is extra practice with the trade